Hello, good morning or good evening, everyone. Let's wait for 1 or 2 minutes before we get started. It's truly an exciting time to learn AI. And I was just listening to some AI generated music. And I'll probably share with you a little bit. It's quite fascinating. Because probably even a few months ago, the AI could definitely generate coherent text and can definitely generate amazing artwork, paintings, probably poem. But the AI music generation tend to be left behind. So the music generated by AI seems to be very generic and very lack the rhythm and attractiveness. But I was searching AI music generation. I found this new beta version called Udio that is fascinating to me. So not only it generates the lyric, the melody, but also it make synthetic human vocal, so you can really hear this a coherent song playing out, and you can write your own prompt to generate new songs, or you can use, there are a lot of different categories, there are pop, there are blue, etc., that you can also mix together different genre to create new songs. It's very interesting, and also I think the generated songs sounds pretty good. So let me share with you about this, and you can play around with it. Probably some of you are musician or music lovers, but probably we never thought we would enjoy music generated by AI. So let me share with you this. This is called Udio beta. It's still in the beta version. And all those songs has been generated by AI. So they have country music, rock, hip hop, pop music, etc. You can listen to some of them. I think they of course they are not really the best songs you've ever heard, but it at least it makes a lot of sense. Um, and maybe we can just play one of this. Oops.
Uh, Hi, Professor. I don't think I can hear it.
Yeah.
Yeah, you can listen to the rest. This one is only the music with no human vocal, but there are some with human vocal that if you listen to them, you probably can't really differentiate whether this is a machine-made vocal or it's a real human being singing the song. It's pretty awesome. So feel free to check it out. Okay, so that is for today's amusement before we get something serious. Okay, so let me stop sharing so we can all listen to Jingyi's presentation. Where is my I had hard time. Oh, okay, stop share here. Okay. Okay, so enough entertainment. We need to get things serious. And let's see, do we need another round of introduction? I think we have a newcomer, Qiping. Maybe Qiping, do you want to briefly introduce yourself?
Okay. Hi, Dr. An and everyone. It's great to be here to join this AI interest group. And I have reviewed many awesome videos on YouTube, and I know that you are doing an amazing job for this group. And it's my great pleasure to join this group and learn from the most latest AI research as well as applications. And my name is Qiping, and I'm an assistant professor of epidemiology at Clemson University Public Health Sciences. And currently, one of the research project related to AI that I'm doing is related to applying AI integrated algorithm to support the caregiving for older adults caregivers. So I'm excited to learn more about AI in this group, and hopefully in the future, we can explore some of the directions. Yeah, great
Yeah,
to see everyone.
wonderful. Great, great. Thank you for the introduction, and you're definitely welcome. So yeah, we have our previous students, current students, collaborators, friends, all in this space. So the only reason we are here is to share what we learn, because we do need many pairs of eyes to look at things, especially given how rapid AI is developing. And I had the opportunity to listen to Qiping's presentation at the AAHB conference. And yeah, you guys are doing amazing job creating this the app, the native app or probably web app to help older adults. And I'm sure we can find some ways to collaborate and maybe embedding some AI components into the app development. So great to have you here. Okay, so without further ado, I think we should get started. So many of you know Jingyi already. So Jingyi is a doctoral student at Shanghai Sport University, and she previously attended many of my AI workshops, and later on AI certificate program. And she learned a lot about large language models. And today she is going to present, I would say, state-of-the-art large language model applications, so-called RAG. So we previously introduced RAG, but today she is going to give us a more in-depth looking into RAG and how she incorporate that into her own research project. So Jingyi, the floor is all yours.
Thank you very much, Professor An. I'm very excited to join today's meeting and share something really interesting and useful for our group. And my name is Jingyi Huang, just as Professor An said. I'm a PhD student at the Sports University of Shanghai. In today's presentation, let me share my screen. Okay. Sorry, please wait a minute. Sorry, I need to leave this meeting and go back to share my screen. Sorry.
Okay, no worries. Yeah, there's always technical barriers, especially in China. There were a lot of restrictions regarding the AI platform use, subscription, even for Google. Yeah, a lot of practical issues to deal with. Okay, so yeah, we'll wait her to be back.
Okay.
Okay.
Could you see my screen now, Professor?
Yeah, I can see your screen, but it's like Zoom.
Yes.
Oh, okay. Yeah, we can see now. Yeah.
Yes, sorry about that. Anyway, in today's presentation, we will talk about how to use the artificial intelligence to specific health communication practice. I mean, fact checking, especially during the public health emergency. I need to, okay. And I'm very happy to showcase a recent research project about the COVID-19 fact-checking, which was raised by Professor An. It's really a brilliant idea to use the RAG to do fact-checking on medical and public health issues. We got pretty good results, I thought, and I believe this research topic has quite potential to be progressed more in the future. And then I'm going to take one step further. I want to talk about how to use the advanced RAG to improve the fact-checking ability of large language models. In this section, I would like to provide 3 simple but useful demo files of advanced RAG in practical fact-checking projects, making it more clear how powerful these techniques can be. But actually, I'm not an expert in this area. So if you guys have any questions, comments, or there is something wrong in my presentation, please feel free to turn on your microphone or put it on in the chat box. I'm not sure I can explain all things in this area, but I think it would be great if we can discuss a little bit about it. Okay, let's dive into today's topic. And before we talk about fact-checking, I thought we would start by going through why we do fact-checking research, right? And how important it is to ordinary people and the social system or the whole society. There is a useful concept to explain this, the infodemic. As you might know, the infodemic is a metaphor term raised by the pandemic. It refers to the fast and far-reaching spread of both accurate and inaccurate information about certain issues, including rumors, stigmas, and conspiracy theories, right? Which means it could be very complex to measure and deal with. Actually, there is a long history of research on infodemic and related issues. I guess it can be 100 years. And go through this research history, you can find that the so-called infodemic can be very attractive to scholars whenever there is an emergency in a social system or the whole society. For example, you can see many scholars paid much attention to rumor research during and after some weapon conflicts between countries, and also after those critical political events occurred in 2016. You can see people from different places were talking a lot about fake news and the post-truth, right? And also during COVID-19, the infodemic became a very popular term used by scholars, medias, and the public. The main fact we can see in history is that every time during the emergency in human society, the need for information and the speed at which people exchange information and ideas, and the value of information in a specific social system will increase quickly but the quality of the information usually not. Then what we call an infodemic happen. Information with uncertainty can transmit so fast and lead to far-reaching consequences, just like a real pandemic, very depicted, right? And during a global public health emergency, such as the COVID-19, an infodemic can lead to confusion about the benefits of medical and public health treatments and impact on risk-taking and health-seeking behaviors. There were many weird treatments of COVID-19, just like I don't know, drinking hot water to cure it, or eating bananas, and so on. And based on this, an infodemic can erode trust in health authorities, right? And compromise the effectiveness of public health responses and policies. It's really a big issue. So we could see the infodemic featured in, I don't know, maybe thousands of academic publications and received widespread attention from policymakers and the media. However, there is another thing I want to mention. About this. The term infodemic itself can be misleading as well. The problem is, I'm considering, does the information really transmit like a virus? I think it doesn't, because first of all, a pandemic usually have a clear origin, right? A kind of virus or bacteria. But the infodemic, or you can call that disinformation or misinformation, often has different and unclear origins and components. So secondly, the transmission of the virus almost had no intention. I think few people will transmit the pandemic or diseases to others in purpose, right? But people often exchange information intentionally. Also, in this communication process, individuals have their own minds and feelings, and usually will do decision making by themselves. At least it looks like that. So these individuals will not just be infected by the information, right? Actually, this statement has been criticized for several years in the social science area, which regards individuals as passive and to be easily influenced by the information. In other words, I think we cannot expect the true or high quality information can be a kind of medicine or vaccine to fight against the infodemic, considering the complex nature of the so-called infodemic. Our fact-checking practice should be more than a classification of true or false in a specific and real social system. It should be a reliable guidance, equally accessible for every member of our society, and be a good interaction with quick and multi-round responses, right? So here I think the artificial intelligence comes in as a possible, reliable, and low-cost approach. As a possible, reliable, and low-cost approach for fact-checking. It might, I know it might sound like a paradox for some people, because in the early stage of the development of large language model, there were some scholars, especially the philosophers, claimed that the AI would be very harmful because it could produce fake things, right? But I think this issue should be analyzed through at least two perspectives. In terms of the technology, it's true the large language model can be false and make mistakes in many situations, but we can decrease or eliminate these mistakes by the development of our technology, such as using the RAG, right? And in terms of the other hand, I think the fake things made by AI will also depend on people who construct it and use it. But this should be another affair and not in our topics today. Anyway, here I provide some imaginations about how AI can help in fact-checking for the future infodemic. As a powerful tool, I thought AI could benefit the query and response of fact-checking, can help to measure and predict the information seeking or other health behaviors of people, and provide a new approach for causal inference to related research. And as a legend, the AI generates spurious information and interacts with human beings in the fact-checking practice. Also, it can be relatively invisible as a system or a kind of rule, such as the recommendation and censorship algorithms, right? Influencing the information flow or constructing a new power or something like social order. It could be a big map. I thought you guys could see many possible and specific research questions just behind this piece of slides. All of these things would be critical to the health and the well-being of populations during a public health emergency. Today, we have a recent research case here, and I think it can be a good starting point in this area. In this research case, we applied retrieval augmented generation to improve the fact-checking practice of COVID-19. At the beginning of this project, there was an important point is to prepare the database of reliable knowledge, right? So here we collected over 110,000 research articles from peer-reviewed journals from 2020 to 2024 without duplicates. To be more specific, we collected the title, authors, published year, published journal, and abstract of each article, and ensuring efficient information in our database. As you know, most of these high quality papers should contain a well-structured abstract, right? Which makes it more convenient for our research case. And then I did some necessary data pre-processing, right? If you have watched the talk about RAG from Professor An, and I believe you will be very familiar with it. Both of them are very useful and very convenient to use with Llama Index or the LangChain. And also, I'm going to introduce some advanced RAG techniques used in this case later. So here I will just go through the workflow quickly. Firstly, I loaded all of my data sets and trunked them into small pieces, right? Secondly, I did embedding to the whole context knowledge, setting the authors, titles, and other information as metadata. Thirdly, I set different retrievers based on vector bases and combined them as a merge retriever to improve the accuracy of fact-checking. And finally, I tested this RAG model with 2 different datasets. One contains 500 claims from real data, and another contains 500 claims generated by GPT-4 based on our datasets of related research papers. I would like to showcase maybe 1 or 2 queries and responses with you. For example, query 1 said, zinc water won't cure the COVID-19, even though zinc water contains quinine and synthetic hydroxychloroquine. I think I pronounce it right, of quinine. And the response said, true, zinc water itself does not cure COVID-19, right? And its content of quinine, if any, does not justify its efficacy against the virus. This answer is correct, and also it provides reference, contains title and the authors, right? Which make this response relatively reliable guidance for user maybe. And the response to another query from generated data contains reference as well. As a result, our RAG GPT-4 with merge retriever got an accuracy of 94.6% in the real data, and 98.6% in the generated data dataset. Not 100%, but still quite reliable and much better than the baseline, right? I thought it could be a critical treatment during an ongoing public health emergency by building and updating a well-structured RAG for a large language model to respond to the infodemic. And according to the research result, we can see the GPT-4 model could perform better with the generated data. It may be because the large language model is better for detecting claims that contain a more formal and scientific writing style, I guess. Actually, some papers have proposed that the large language model might be possible to do fact-checking by detecting the tone or narrative style of a specific sample, including a research report about the performance of GPT-4 region. I think it might be an interesting question we can explore in the future. Sorry, I just need some water. And so now we know the RAG can be very beneficial in fact-checking of COVID-19. And I'm sure that it can be powerful to help respond to infodemics in different areas and situations, which could be the next direction of our research. And in this COVID-19 research case, we applied the merge retriever to improve the performance of the RAG model. So here in the second section of today's presentation, I would like to introduce some useful advanced RAG techniques I think this can be very helpful and easy to take into practice, and I'm going to show you how to use some of them in detail. Here on this page of slides is a naive RAG, right? It's pretty powerful and simple, but we still want it to be more powerful and accurate. So here we go. Here we get into an advanced RAG. All of these colored lines and marks can be a kind of approach to advanced RAG, including including different parts of the whole workflow. But I think I need to say that what I put in this graph are not the all techniques. Some of them are just difficult to visualize in a single graph. In general, what we call
sorry, Jingyi, could you go to the previous slide? Yes, so the previous one. Yeah, go. Yeah, so because some of the audience may not be familiar with the RAG, so probably the majority of you are familiar with it, but just for the sake of others who are new to RAG, maybe Jingyi, you could just give an overview of what is RAG and how to interpret this graph, so that to help people to catch up in this new idea.
Yes, thank you, Professor An. As for this purpose, I think this can be more easy to understand, right? Here is a naive RAG. It's named by retrieval augmented generation, which means we will use our own documents with specific knowledge, especially in a specific and I guess academic domain, to improve the ability of large language model to answer the related question, the question related to this domain. The basic action we do is to put these documents into the workflow of this large language model by something like vectorization. We will do embedding to these documents and make it to the vector store index, which make the large language model can find the related documents by using something like similarity search, right? And when we finish this indexing, you can imagine a user put a query in to the large language model, and then this model can find the related documents by doing the similarity search. Actually, the similarity search is not the only way. Maybe I can talk it later in the last section of this presentation, because we are going to go through the large graph RAG, right? But anyway, by doing this, we call the RAG for the large language model, the benefit is the large language model will basically it will make less mistakes when this model are meeting the very specific or professional questions of related domain, because we give this model the documents, right? It's something like this model having a test, but you give it a book about this test. Does it make sense? Okay. I think it makes sense to me. So so I will continue to the next part. So here, advanced RAG is different. It's a little bit different because it refers to a second paradigm in the development of RAG, which means we will put efforts to improve the retrieval quality by applying pre-retrieval and post-retrieval strategies. In the pre-retrieval process, the focus of scholars is to optimize the indexing structure and the original input query, right? The optimization of the index, it contains some specific strategies, including, I guess, enhancement of the data granularity, and adding metadata and mixed retrieval and so on. For query optimization, it usually contains query rewriting, transformation, and others. It can be taken into practice just by prompt engineering, I think. And in the post-retrieval process, the main approaches include re-ranking and context compressing, aiming to integrate the context with the query more effectively and improving the performance of RAG, right? Also, the re-rank and other techniques is are very convenient to do just using LangChain or Llama Index. And all of these strategies will involve many specific useful techniques. I think the techniques I'm going to demonstrate later could be classified as context enrichment, retrieval granularity enhancement, and maybe structural index. The last one will contain the construction of structured data, the knowledge graph, right? Which could be very interesting and helpful. Here, the last thing I want to mention here is, as you can see, both of the naive RAG and advanced RAG emerged as a chain structure, right? But actually, in the real practice of RAG, the modular RAG will be a more flexible and effective paradigm. The flexible construction of the modular RAG flow showcases something like adaptive retrieval through techniques such as layer and self-RAG, which could bring more possibilities in this area. And I'm still learning how to practice with it. But I think it would be very helpful in fact checking, and maybe the broad issues in the health communication research area. And also maybe we can talk about it in detail in the future. All right. Now I'm very glad to share 3 powerful and practical advanced RAG techniques. The first one is the merger retrieval, which was used in our COVID-19 fact-checking project. As you can see on this graph, the merger retrieval refers to the combination of different data sources or the same data source, but using different embedding approaches. And then you can filter and reorder the retrieval results to reduce the context size, right? Actually, maybe in the future, we will not need to consider the context size to the large language model, because I think the technology of the large language model will develop very quickly. Anyway, here, something also the reduce the context size is something we call it context compressing, right? And it will make it more accurate to generate answers. And this technique was proved to address a problem, a very specific problem named lost in the middle, which means in a long context, the large language model will perform better when information occurs at the beginning or the end of a long context, but significantly degrades when accessing information in the middle of a long context. It's just a phenomenon. Yes, just a phenomenon. And some people propose that when the number of the documents you put in this model increase over 10, the lost in middle problem will happen. So here I'm going to take a quick example and showcase how we can use the merge retrieval to improve the performance of large language model in dealing with long context. I used the text document of the tale story Peter Pan. Actually, I didn't read this story, so I just grabbed some questions, some claims, and related explanations, or you can, or we call it ground truth, right? And I think the ground truth might be not very accurate without evidence, but I think this will, I think it's fine, doesn't matter, because we just need to do the compare the different techniques, right? So you can see in my Jupyter lab, this is the code of how we apply the merge retrieval in a specific case. The first step is to prepare dependencies, right? And the OpenAI API key here. And then we need to load the text of Peter Pan. Here I use the plain text without any metadata, just for this example. But actually, if you want to apply RAG in your own research cases, I think you would better set metadata. It can make your data more structured and improve the accuracy of your model. Yeah, we will talk about this a little bit more in the section of the knowledge graph for RAG. And the next step is to trunk this text into small pieces, using a text splitter provided by Langchain, right? And when this done, you can take a look at your documents. Here we have 374 documents, right? And then you will need to set an embedding model. Here I use the text embedding 3 small from the OpenAI. And also I use the QDR range as a vector index store. And also the QDR range suppose applying the maximal marginal relevance search. It is a good approach to finding target documents related to your questions and make sure the diversity of the context. At the same time, if you want to know more about this method, I think you can easily find it in the documentation of Langchain or the QDRN. And then we can test the baseline of our Peter Pan fact-checking project with GPT-4 here. We define a large language model, and prompt template. We set up a direction, right? And all of these.
Jingyi, just one quick comment for those who are less familiar with the with some of the terminologies there. If you could scroll up a little bit when you talk about the QD-RAN.
The QD-RAN. Okay. Thank you very much,
Yeah.
Professor.
So yeah, just for those who are less familiar with the vector store, there are a lot of vector stores to choose from. The
Yes.
QD-RAN, the Chroma, the FAISS, FAISS. So those are commonly used local vector stores that you can save the database in your local computer. But of course, if you have huge data set, right? So now Jingyi has a pretty small data set to be stored as a vector database. So it is feasible to store that in your local drive. But sometimes you have huge amount of data, probably millions, if not billions of records. In that case, storing the data in your local database is not feasible, or it just takes too long. So in this case, you would rather use some online, maybe MongoDB, or maybe there are plenty of others, PyCon, etc. That they charge a fee, but it's very convenient that you basically insert the entire data into the vector store that is hosted on the cloud so that you can access remotely. So previously we had a session introducing PyCon. That's probably we have 2 sessions introducing PyCon. So if you're interested in how to store a huge amount of data as vector store on the cloud, you can check the previous video recordings. And another comments for Jingyi, when she defined the large language model, she set the temperature to be 0. This is usually, I would say, recommended practice because, the temperature is a hyperparameter for large language model. And the larger the temperature, the more creative the model is going to generate the text. Being creative just means that choosing the words more randomly. But in this case, because we are doing a retrieval task and precision is the key, so therefore we set the temperature to 0. But if you were writing a poem or poetry or lyric, then you could set the temperature to be a lot higher, maybe 0.5, 0.8, etc. Yeah, okay, so that is just some inserted comments for those who are unfamiliar with those terminologies.
Thank you very much, Professor An. It's a great comment. And also, I want to say that actually the different vector store you will choose, it will contain different features or advantages. Just like Professor An said before. Actually, the Pine Core or other other vector store index will be better than here we use the QD-round or the faces. Faces. These three things we used here. But just for take it as example, I think the QD-round is enough. Yes, and I think we are okay. The next step, just after set up a reg chain for our project, I prepared the ragas for evaluation of the results. Actually, ragas is just one of the evaluation methods, right? You can choose to use the true lens. The true lens, its logo is a blue squid, and it has a very nice dashboard to observe the performance of your model. And also you can choose to use some basic evaluators provided by Llama Index, right?
So Jingyi, maybe you could scroll up a little bit, and could you briefly explain, because probably the majority of us are unfamiliar with the LangChain grammar. So when you define the rag chain, the setup, the rag chain, would you go through this line of code so people understand how to use the LangChain type of grammar? So this is a typical example.
Okay, sure. Thank you very much, Professor An. I think I'm not sure I can explain it very well, but the rag chain I think is very convenient to use, because you in the rag project you will need to define your retriever here as a context, right? And you will use a method named runnable pass-through to pass your question to the large language model, and you here you will put you will pass your prompt to into this chain, and the large language model here we defined just now into the chain, and in the end of you will write this method here, and this you can see here the marks is just the template of the rag chain in the long chain. It will be different in the when you are using the Llama index, right? But all of this, I think it would be very convenient to use. You just need to write this. Very easy to understand, because all of these things are defined by yourself before you get into setting the rag chain, right? And also you need to put this rag chain in your which may be the something like the query engine in the next step, and then you can run it and to detect and generate related answers, right? Very convenient to use. But here there is another thing I want to mention about Ragas. Ragas is a very powerful tool to evaluate the results generated by large language model, and you can find how to calculate all metrics here in the documentation of Ragas. But actually, I think the evaluation of large language model is a relatively difficult task to do, because you cannot evaluate just depending on the accuracy, right? And also the generated answers could be different each time you run your model. So here we got 6 question. Actually, is claims and ground truth here. But if you want to get stable results of your model, 6 is not enough at all. Maybe you need 600, even more to make your make the evaluations of your results stable, right? And also here we as you can see, the answer correctness is what we I think is the important things we will focus on in this project, which means the accuracy of the generated answer when compared to the ground truth. And then we can run the RAG chain and make the evaluations. Actually it will take 5 to 10 minutes. So I would like to just showcase the previous results here. And you can see, we just go into the last results. And you can see the answer correctness is very low with the naive RAG. It suggested some of the claims might be very difficult for a naive RAG to detect and explain, especially the last one claim, right? I think because it's very detailed, and also there seems no direct content about the death or revival of Tinkerbell in the story. So the naive RAG responded, the context does not specifically state that she came back to life in the blah blah, right? Which is totally false. But let's see how the merge retrieval will answer. The first step here is adding.
Sorry, Jingyi. Just for those of you who probably are a little bit puzzled, because previously what Jingyi showed you in the fact checking of COVID-19 claims, the RAG seems to be very effective. But now, just switching the topic into
Yes.
a fiction, a novel that many of you probably read in your childhood, and that seems to be pretty straightforward, because starting in childhood, you may read some novel, science fiction like this, right, or fairy tale, I would say. But
Yes.
why the RAG performs so poorly, in this children's storybook compared to scientific
Yes.
claims? So maybe Jingyi, you could provide some intuition why this task actually is a lot more complicated than the COVID-19 fake claims.
Thank you very much, Professor. It's a very good question. And in my personal opinions, I thought it's because firstly, the claims here are very difficult to detect or explain, even for the human beings. Like you can see, just the last one, the Tinkerbell drank the poison, but she came back to life. As I said before, it seems that there was no direct content about how about this claim, and also some claims are just too subjective to answer for a large language model. For example, here the claim mentioned Wendy likes Peter, but Peter doesn't like her, right? And another reason I think is the abstract of the research papers we put into the COVID-19 rack, right? Most of them contain well-structured text. In even the abstract is well-structured, and I think the large language model will find the related information in a single sentence, right? In a single sentence of the research paper's abstract. But it might be very difficult to find the related answers or content in a single sentence of a tell story. You will need to consider more context before and after this sentence, and I'm going to talk about how to improve these things in the next part. Yes, this is what this is just my personal opinion, and could you provide some insights, Professor An, about this question?
Yeah, I think I agree with you. I think no, please, we are just hypothesizing, right? We don't know exact
Yes.
reason, but and I also actually I've tried with Peter Pan with little success using naive RAG. I think the main reason, as you said pretty well, is that the context window is very large for Peter Pan, or I would say fiction in general, because the description is vivid. It spans over probably a few paragraphs, so that there's no single sentence that you can detect to that contains the knowledge. So therefore, some kind of summarization is very much needed to condense the information into probably one or few sentences, so that it make it easier for the retrieval to get the knowledge. I guess that's probably the at least one of the major reasons there.
Yes, thank you very much, Professor An. And so let's see how I must speak quickly. Let's see how the merge retrieval perform in this task. The first step, we will prepare different embedding model for the merge retrieval, right? The embedding model I used here was from the Hugging Face, and then we import the libraries for merge retrieval from LangChain, and we built the this is another name of the merge retriever to avoid the loss in the middle. The problem I mentioned before, two retrievers, right? And we combine the two retrievers and the merge retriever, and you can test the combined retriever. And here, I think you can choose to build a filter. Here you just by the LangChain. Actually, there is not only one filter method or method you can choose, but here I just choose the clustering filter, and I choose to use a reorder method here, which means when the large language model gets the related documents, or you can call it trunks, right? It will reorder it, just like something the re-ranking model do in the Llama index, but a little bit different. Anyway, here first we put the simple merge retrieval without filter and reorder here in the LangChain, and run it on the Peter Pan dataset, right? Just and same as before, and we do the evaluation of the results, and the result, you can see the mean value of the answer correctness increased to 0.5 5.5, right? Even for the last difficult claim about death and revival, the advanced RAG would say she was revived by the belief of children. Comparing the naive RAG, it is relatively more detailed and accurate, right? Here you can see. Yes, and the answer correctness is higher than the naive RAG. And just for example, I also tested the last claim using the merge retrieval with filter and reorder. You can see the answer also close to. You can see the answer will be also close to the ground truth and even contains more details. But this one didn't get a high score. Maybe because it contains too much other information, I guess. Okay. This is the merge retrieval, right? The next technique I want to share with you guys is the sentence window retrieval. It's very powerful. Instead of the merge retrieval, the sentence window retrieval was applied to address the fragmentation problem, which means the paradox that we can get higher similarity and relevancy by making smaller trunk size. But when we make smaller trunks, the quality of the retrieval will decrease. I thought this was because in the naive RAG, we usually use a similarity search to find related documents, right? However, when the trunk size is very small, we will get a lot of single pieces of documents very close to the question or claims, but lose the context information of a single document, which will decrease the quality of answers. So sentence window retrieval is an enrichment context technique that refers to searching related single sentence and taking the sentence before and after this sentence as a corresponding context. In this way, by this way, we can improve the relevancy with smaller retrieval granularity and keep enough information in the whole retrieved context. We can we can apply this technique to our Peter Pan fact-checking project very easily with Llama Index. To begin with, we also prepare the dependencies and API key and load the text using the simple directory reader provided by Llama Index, right? In the second step, we will use the sentence window node parser to set the window size here. Of our sentence window retrieval RAG. Also, we need to set the embedding model used here and put them together. Embedding
Sorry,
model here.
Jingyi, a quick question. You set a window size to be 3.
Yes.
Does it mean 3 sentences?
Yes, I guess if I remember it.
Okay.
Yes. But you can test maybe 3 or 5. But in general, we will use 3 here for this tell story. It will be enough, I think. Thank you very much, Professor An. And then we will need to we set the embedding models here, right? And we will set the sentence context and the storage, and also the vector store index here. Just a little bit different when we use the long chain, but all of this will be very convenient to use because you just remember you will need to set the sentence context, use the things you defined before, and you will set a vector index store here, and you will need to set the storage context, use the vector store you defined before, right? I think it's it's relatively easy to understand. And then we will need to prepare the post processor and the rerunner. Also, if you are interested in those two, you can check it in the documentation of the Llama index. And the next step is to prepare the prompt template and integrate all of these things by using response synthesizer. Also, if you are I think you can watch the talk video about the Llama index by Charles for our group, right? It provides a great introduction. Then we will need to build a query engine based on our sentence window retrieval RAG and run it on the Peter Pan query engine here, right? And we can have a test, and then we will run it on our Peter Pan dataset. Here, actually, when I applied the RAGs to evaluate the results, there was something wrong, and I could not get it work. So I just wrote several lines of code to debug it. Here, just like here. And anyway, let's see the final results of the sentence window retrieval RAG. As a result, you can see it was also better than the baseline, which was lower than 0.4, right? At the same time, this advanced RAG also can detect and explain the claim about the death and the revival of Tinkerbell. The answer said she does indeed begin to die, but she is revived by the belief of children, right? And got a higher answer correctness score here. Based on it, we can see the sentence window retrieval RAG can improve the performance of the model in detecting a detailed claim as well. And I thought it would be pretty helpful when you need to deal with some data or questions very context dependent, right? Such as, I don't know, the misinformation of local medical transformation based on an immigrant culture, something like that. Great. In the last section of today's presentation, I am very happy to go through a simple introduction of the knowledge graph for RAG in specific practice. In general, the knowledge graph is a collection of nodes and edges that represent entities or concepts and the relationship between them. It is a structured way to organize these representations of real-world entities and relationships. Here we get a very simple knowledge graph. It contains two nodes and a line of those two nodes. They can consist of a single cell in a knowledge graph, which is called a triplet. A triplet would contain a subject, an object, and a predicate. For example, in this triplet, the subject is Da Vinci, the object is Mona Lisa, and the predicate between Da Vinci and Mona Lisa is painted, right? According to this simple knowledge graph, we can develop a link between Da Vinci a person, and the Mona Lisa a painting, and get an understanding of the relationship between Da Vinci and the Mona Lisa. And the graph can be very helpful based on the relationships in the structured data. It will provide enrichment of context, just like the merge retrieval and sentence window retrieval. And also, some scholars proposed that the graph RAG can be very helpful to develop the reasoning ability of the large language model. Additionally, we can use the knowledge graph to link knowledge from different areas, not only based on the similarities between vectors, but also on the real relationship between them. So here we step into the knowledge graph RAG. The first step here is to import some modules from Llama Index, right? And also you can use LangChain to do this. I choose Llama Index just because it's simple enough to make an example. Then we will need to load the text, just the same as what we do in the what we do before. And we set up the service context and storage context here with the graph store, right? Here I used the simple graph store provided by Llama Index, and I thought it would be the same or even better if you choose Neo4j or Nubular Graph Store. You can find how to apply both of them in the documentation of Llama Index or other places. This process of building the graph index will contain the named entity recognition, right? Because we need the nodes and ages from Peter Pan text, and the unstructured data to construct the knowledge graph. It is very convenient to do this because we have many powerful pre-trained models for named entity recognition, right? Additionally, just one thing I want to mention is the chunk size. The chunk size here, according to the documentation of the Llama Index, it seems that it is a chunking based on a single sentence, but I'm not sure. I tested it in several times, and I noticed in our Peter Pan case, a smaller number would be better, but I thought it would be different in different situations. Okay, the next step is to create it. A graph index. Here I built two indexes. First one is a simple knowledge graph index without embedding, just the knowledge graph and the templates in it, right? Another one. Another one is a graph index with embedding. Here, right? We will use it in the hybrid search later. Then we will need to create but before the creating of the query engine, we can take a look at these two knowledge graph. Yes, it looks similar, but actually you can see the second one will contain more context information here, but I think I don't have much time to explain it. So let's just continue. Here we need to create a knowledge graph keyword query engine. You can choose keyword here without embedding, right? And without any this means you will use the keyword for searching and not include the text related to the nodes and edges in the knowledge graph. Also, I used RAGAs to do evaluation, and as a result, the simple keywords graph RAG could beat the mean value of the answer correctness to almost 0.51, right? Better than the baseline, the merge retrieval and sentence window retrieval, right? And you can see here, the answer to the last claim contained good detection and promising details, right? Yeah, great. The last one I want to showcase is a hybrid search. Hybrid search for GraphRag. You know, it is really fantastic that we could combine the knowledge graph with embedding the vector store index, right? And I thought it would be very useful. It would be very useful in many practical situations. Here I created a hybrid query engine. Also, it is very easy to do using the Llama Index. Then I run the hybrid search engine, hybrid query engine on our Peter Pan dataset, and as a result, as you can see, I got the best performance of answer correctness in this presentation. Also, we can take the last claim as an example. You can see good fact-checking with explanations and comments related to the specific details, right? And also the score here is very high. I think it's the highest in this Peter Pan case. Okay, all of these are what I want to share with you today. Thank you so much for your listening. And to be honest, I'm not sure if I could explain these techniques and our research case in very detail. On the other hand, I thought all of these were just small pieces in the whole big map of RAG. And there would be lots of things and issues to discuss about. And I thought it would make more possibilities of fact-checking for the infodemics. So I hope my presentation will make sense to you, and I'm looking forward to any questions and comments. Thank you very much.
Yeah, thank you, Jingyi. And this is fantastic. I can definitely see that you spend probably hours, if not days, working on these projects, and both the presentation as well as the richness of the programming code that you develop are going to be immensely helpful, probably for all of us. So you are very modest to say that you know little about RAG. So you're definitely probably the most knowledgeable person on RAG, at least in our team. And really no one will be able to comprehend and know everything about RAG. I don't think that's ever possible because the RAG didn't exist 2 or 3 years ago. And just for the last probably 6 months, I see a tremendous emphasis on RAG and suddenly become really popular. So no one has a hand of everything about RAG. But I believe we are truly at the frontier of RAG implementation. I do see a lot of potential ways we can use RAG to ground the large language model, to substantiate our knowledge database and for many different applications, evaluation, fact checking, fighting misinformation, etc. I think the potential applications are really countless. So thank you so much, Jingyi, for the great presentation. You probably caught a cold, as I can guess.
Yes,
So
yes.
hopefully you're going to recover soon. And any questions from the audience for Jingyi? Any question, comments? Just unmute and talk. No, okay. So and then Jingyi, please send your presentation slides and the programming code to Yuyi, and Yuyi is going to upload them to our website, YouTube channel, and GitHub, so everyone can learn from your wonderful work.
Of course, of course.
Okay, great. Any other comments, questions before we end today's meeting? Okay, so that's fantastic. We'll see all of us in 2 weeks. I haven't decided the next topic. So if any of you want to self-propose a topic, just shoot me an email and we can definitely discuss. And we'll see each other in 2 weeks. Bye, everyone.
Bye, Professor and Yuyi, and everyone. Thank you very much.